As a next step, we come to the panel discussion. So I would be happy to come everybody on the stage. And I guess we can, in the best way, introduce yourself in a short round.
Yeah. Hello.
Yeah, maybe you start. Yeah.
Okay. Can you hear me? Yes. Hello, everyone. Thanks for this opportunity for the organization. My name is Nelson Garcia. I come from Spain, from the Center of Automotive Technology in Galicia. We are a technological center focused on consultancy. That means we can help you into the development of your technology.
Yeah, my name is Mirko Bovo. I work as a technical expert in thermal management at POWERTRAIN Limited, which I'm curious to know if you know what it is or not. If you don't know what it is, I'm curious to know if you wish to know what it is or not, which probably will make some sense. Raise of hands. No hands want to know what POWERTRAIN is? One. Okay. I think I'll take the time later to tell you when I have the chance, even from here, so I can do it once and for all, if we have the time throughout this session.
Thanks a lot.
Oh, my name is Albrecht. I'm working as a lead engineer in for electrical systems as a system responsible person for electric heating at Webasto. So we're sitting close here to Munich in Stockdorf. And yeah, actually I'm having a material engineering science background coming from the polymer side, so polymer and yeah, polymer engineering. And with Webasto, I was also changing my direction towards the system and heating direction.
Thank you.
Hello everyone, this is Christof from Toyota Motor Europe. I'm an engineer at the R&D division, and specifically in the vehicle performance engineering division, where I work in the model-based simulation team. So what we do is we look at the interesting European technologies and try to prove their worth, their value, and then basically give that back to Japan, because they still make the big decisions, but we try to push them to represent the EU customer. Thank you.
Thanks. Yeah, and myself, I guess I do not need, once again, to introduce myself, so I will be happy to be part of the panel discussion as well. Maybe I can say a little bit to my background, where I come from. I'm coming from Austria. Maybe somebody already recognized from my voice that I'm not from English native speaker and not from Germany, maybe. So I'm located in Graz in the headquarters and traveling a lot, and it's always nice to hear different opinions and have potential to discuss about different direction and views. So today we have the challenge to talk about how can intelligent thermal management unlock longer range, greater efficiency and better comfort in the electrified vehicles. So we had before already the question, what is the ideal best thermal management system? So it goes somewhere in that direction. So on the one hand, I guess we can start to give our opinion to that, and then for sure I would be happy if we can include you in the publicum as well a little bit with some questions and statements at the point.
Okay, can I start? Artificial intelligence is a very, very nice tool nowadays, in my opinion, and probably we have used this in the past as algorithms, but now it's more famous, more knowledge. But in my opinion, the key is the data, the use of data for this. Two types of data. The data, for example, for different, because we are talking about long distance trips, the data from the different vehicles or from the different users with the aim to train the system. But also the current data, that means we need to be connected to the cloud to get information, for example, for forecast, or in order to anticipate this and to evaluate the conditions of the battery, and also to know the location of the charging stations. That just to say that the artificial intelligence is very good, but The challenge is how to use this data, how to access to this data to be used in a better way.
Mm.
It's my turn.
If you want, for sure.
I mean, I'll pick up from what you just left. Start arguing with for a proper progress, then you will need good data, and they are hard to get by. And then most likely you will need good models that make a sufficiently accurate representation of the reality you want to optimize. And then you, instead of using brute force with artificial intelligence, you can use physics-based artificial intelligence models, as we are now trying to implement, for which you do not have just a nonsensical, I mean just a pure chance investigation of such a large spectrum of data that you don't really trust, but you already build physics model, you validate them, and then instead of bluntly assuming an answer, you just have a physics guide one, which at least the fundamental law of heat transfer and energy balance and energy storage into it. So I still think the tool is definitely very interesting. It will accelerate the process, but if you feed it with poor information and you don't lead it, it's going to possibly mislead you at the end.
Mm.
That would be my take on these processes, these tools.
So you, if you understand you're correct, you mean as well the way of how this root cause or decision taking in the right way, or because if you take the wrong decision with the data you have, then you also go in the wrong direction.
Correct,
at the end,
right. And if the decision is taken by a machine or a human or in between that has no fundamental understanding of what's going on, you might end up in a field that is absolutely irrelevant.
Mm.
One side. The other side, if the data you're basing your decision on are corrupted because the sensors are not good or not, there's also another problem. So for me, and what we do a lot is to loop between modeling and vehicle and powertrain measurements, and at times even tell that probe is wrong because there is no way that in that position you have that temperature. And hold and behold, the engineer go there and the thermocouple is moving into the air rather than be stuck in the engine mount in which it should be mounted in this specific case.
Yeah, good point.
So each of the individual topics that are mentioned are somewhere resolving around energy consumption, energy need. So actually, in the best case, there would not even be any energy need or any energy consumption, but how to actually get there or how far can we get there. All of us getting to a warm country where no heating, for example, is needed, everything is always beyond 20 degrees. Actually, I guess it's not an option, and also global warming, waiting another 200 years with the actual global warming rate to achieve those temperatures is not the goal we want to achieve. So actually reducing the energy we need and getting clever thermal management, in my opinion, is the key. And going the road with the heat pump, for example, shows already in today's vehicles that the energy consumption for thermal management is being reduced by using the high COP and the heat pump can provide to the system. So getting good thermal management systems with a high efficiency, in my opinion, is one of the key ways we want to go. And also a clever thermal management system, because, for example, let's take an example. When people are driving with an electric vehicles on just short ways to work, to the bakery, for example, then in the morning you step into the car, you need to heat up the cabin, the battery, for just, let's say, 10 minutes of driving, and then it cools down. It's not needed all the day, throughout the entire day. And then again in the evening you need to heat it up again, just again for 10 minutes of driving. So if there are better ways to use our energy and to also maintain the energy spent, like for example, to store energy, to store heat, within phase change materials, for example, are one example which way we could go there to reduce the overall energy consumption. Is for me the way to go. And if we look at stationary units like heat pumps for structures, then it's also one way we could have a look at and see what we can achieve with the same assumptions, with the same technologies, and we should see what we can transfer to the automotive industry to improve our heat pump systems and to improve the thermal management systems.
Thanks a lot.
I think my partners here have some good points, first of all on the data, but also on the use cases. And it's also been touched upon in our challenge session. Basically, we're on the same line here, saying that we want to use the data, learn really what our customers are doing, and tailor our control strategies or heat pump systems towards it. And maybe the luxury being as an OEM, we kind of have some customer data, if of course GDP allows, to look into it, and we need to be clever in that. So it's an area we're investigating because now currently, of course, it's all generalized. But in an ideal world, we would like to optimize our controls for each individual customer. So yeah, if you have any experience there, or if you have any thoughts, please, I'm interested.
Yeah, I would maybe say two comments as well, because we have, I guess, two things. The one thing is having an intelligence control, and the other thing is having the system intelligence to store energy or something like that. And I remember, I guess it was 6-7 years back, we did a project where we had a demonstrator car in an R&D project, a public funded one, where we had this phase change material in. And nowadays, on the market, you hear nearly nothing from that technology anymore. I mean, for sure, it was maybe as well not really sexy to have in the backbone a huge phase change material tube or something like that. So you need to find better ways to do it. But on the other hand, I agree to have the energy, what you maybe store during the night when you charge the battery, would be helpful, definitely, to get out of that or to get rid of that in a better way. Will somebody from the audience already comment something or jump in with a burning question? Please. Or statement.
From company HEN, Austria also. I'm in L-type. So the question is regarding intelligent thermal management. What is exactly what you need as intelligence? So do we speak about intelligent hose, tubes, quick connector, pumps, or is for you? So how you will connect all this component with the HPC? So the question is, and how much you are able to pay for that? So this is a very important question. So you will have intelligent tubes, you can have it, but the price will be in the 10 times or something like that. So because we hear every time intelligence, what is exactly, so in which way? So you need to detect the data and to analyze it centrally and make a reaction. So what is exactly your needs for that?
I can answer to this. For me, what is intelligence is what is exactly needed for a customer. Just make sure you grasp the expectations and make sure you can live up to these expectations with the most cost-affordable solution that you can get. For me, that's an intelligent solution. And part of that would be the thermal management.
Okay.
I will maybe comment as well one statement from you in another way. You said, for sure, somebody need to pay for that. And at the moment, I guess this is the biggest headache we have all together in the industries, the OEM, the tier ones, the supplier, the engineering suppliers. But on the other hand, if you have an intelligent system, you can get rid, we had this discussion as well in the previous session, you can get rid of some calibration processes maybe as well. So you might have something where you can teach the system in a better way, train the system, and you have, let's say, something like self-learning calibration on the vehicle level, on the thermal management system. For sure, there is always some safety topics where you might not wait until that gets trained, maybe with 3 times burning the car or something like that.
Yeah.
For sure, I agree, not with all the function and features, but especially with the comfort and the more efficiency might be possible.
I think the question is more from which perspective. So I can say I have an intelligence hose which he can raise his hand and say, I am, the lifetime is the end, please change me. So this is also intelligent. So this is the question, because we speak a lot about intelligence, but what's exactly need to be intelligence? Lifetime, pressure, temperature, price, it's depending, right? So this is exactly the question from my part.
I mean, you had cost. Who's paying for it?
Yeah.
And intelligence is the, so I just have me.
Yeah, sure.
Intelligence will be the ability, as you mentioned, to satisfy the customer better. If you have a system which is intelligent in the sense that you satisfy the customer better, the customer might well be willing to pay for it. And you might well have some cost saving and time, mostly, in the calibration process. I don't think the calibration process is a lot of the actual cost. But if you use the resources you have better, then you need less resources, for example, a smaller battery, and then you will have a car which is lighter and cheaper. So that, in that sense, the cost of the intelligence cooling system needs to be taken to the bigger picture, and it is like, will it be able to indeed use less resources of the hardware, for example, the battery or whatnot, and then return at lower cost overall. That could be an example. I'm not sure you can do it. I have a better solution, but.
Is the question just to look in the future, which challenge we have and how we can, so it's I think we speak about big picture thinking what you have it now. So
with the speed at which information technology is growing, the ability of the vehicle itself to have enough brain to think and learn, given that we are allowed to record and use the data to actually train it, which is binding our hands behind our back in this in this continent, that is not unlikely, I would say.
Okay. Yeah. Thank you very much.
Hello, guys. Linking to what you mentioned about the answering that the intelligence is giving to the customer what he may need, right, or what he needs. Nowadays, usually a customer, when he buys a car or an electric car, he looks at WLTP range. So in that case, even though your system is super intelligent, you are still looking and comparing against a specific cycle that you will not be able to see if that is giving adding value to you. For example, you mentioned about, some of you guys mentioned about driving your car to work every day and you need to heat it up for 10 minutes. That's not part of WLTP. So your customer is buying a car based on one parameter, which is WLTP, but your use case is so far from that you still need to convert that condition to your use case to understand how good is that for you or not. So my question is, how can you sell this to your customer? You know, like, how are you telling your customer, look, my car is more intelligent than the other one, so if you buy mine, even though I have less WLTP than he does, because my car is cheaper and lighter, actually, you will get higher range every day.
Of course, I'm not a marketing kind of guy, but it's a very good question, of course. How do you translate any of this intelligence into value towards a customer? One partial answer to this question might be, EV database. I'm not sure if you know it. It's a very interesting website, and it also not only gives WLTP, but also cold range, medium range, all these kinds of items. Apart from that, of course, it's, I guess, up to the retailers to talk to the customers and make them understand. Of course, that means that the customer already has made that step to one of the retailers. So, yeah, I get your point. It's not easy.
I agree. Also, customer value, in my opinion, should be one of the key approaches. Like to the customer, this should in the end make a benefit. Like he doesn't want to pay 100 euros more or even more just for an effect he cannot measure or cannot compare to anything. Like when I look at the consumption of an electric vehicle, we have the kilowatt hours per 100 kilometers. So to make the calculation easy, let's say it's 20 kilowatt hours per 100 kilometer. And let's say we have a measure that costs 100 euros, but improves the energy consumption by 5%. So 1 kilowatt per hour, 1 kilowatt hour per 100 kilometers is less consumption. And the customer can easily calculate, okay, over lifetime I will need this many thousand kilowatt hours less, which will save me in the end some multiple hundred euros overall energy consumption compared to the 100 euros that I need to pay more to buy the vehicle. So this is also one thing where we should get the technology and the customers together, and which is, I think, also one of the key things that today is often misunderstood. And if you talk to other people, then often you will notice, okay, the ones who are keen to technology may have a good understanding of electric vehicles and how they work, where the limits are. But if you talk to most of the people, let's say, who are still driving fuel-operated cars and do not want to have an electric vehicle about their opinion, they will, for example, say, okay, they do not really get what will be the advantage, or they may they may have a misunderstanding of some things about how the electric vehicle works and what potential there is still.
I guess what is as well a different point of view is two things. The one thing is we change as well sometimes the criteria, especially when you buy an electric vehicle in some areas of the world, you paid no tax, and then suddenly they came up and say, there is a tax, which might be the weight of the vehicle and the continuous power and something like that. So maybe this would change as well the decision how you go for buying a car for some people, definitely. And the other point is, if we take the use case of the car to another view and say maybe this self-driver vehicles with going for a taxi or a people mover or something like that, then the use case and the cashback period maybe is completely different or a little bit more different in that direction. And then the energy consumption and what is learning out of that is maybe much more important to go with that vehicles in a very efficient way.
Yeah.
And on the other hand, maybe comfort is as well something what we at the moment very often not put in consideration. We more focus on the e-drive, on the battery and the efficiency, heating that up or something like that. This really comfort feeling of the driver or of the people in the vehicle is not the highest focus, I have the opinion sometimes, in this taking the decision how the system should look like. Not with all the OEMs, for sure.
Yeah, exactly.
There are some
because
brands
I don't recognize this from one of our customers, our main one.
It depends definitely on the DNA of the customer or of the OEM, which brand he has and what is the value he will sell in the market. But if we talk about efficient energy thermal management system, we most of the time think more about powertrain, battery cooling, putting there some function features in predictive or something. It's at least my feeling.
Yes, I mean, this question is very good because it's very difficult. We are engineers and we think into the energy efficiency and this, and how to translate this into the consumer point of view. And not only this, how to create innovation in our pipeline of innovation, thinking about into the user, or let me say, efficient innovation. It's very important to be a bit close. We are not marketing guys, but we're a bit close to the marketing because, for example, the comfort is very important for the users, but also the range anxiety is because it's very difficult to find this trade-off. But in my opinion, when we develop some technologies and we present this internally with the marketing department, and they says, okay, but probably the user don't evaluate as a very, very good because you increase the 5% the efficiency. But the comfort or the system using the AI, for example, as we mentioned previously, using AI, using AR cameras to evaluate the temperature of the occupants and to adapt these systems to create better conditions is better. Okay.
It's really interesting. I was wondering whether making you, if you are anxious, your heart rate goes up and you become warmer, which then is partially solving the solution. I'm so sorry to go down that way, but then everybody in the car will have to be anxious. I rest my case. I work mostly with hybrid powertrains, and so when I hear this discussion, I feel for pure electric vehicles owners. And I also have the impression that most of the pure electric vehicle owners are aware that range is strongly affected by temperature, right? So the argument at the showroom saying that the range of this vehicle WLTP is this much, and it is so in a wider range of temperature than the WLTP is tested, because it's 714 and 23 Celsius, right? You don't go really cold or really warm. Then probably it's not very hard to explain. And also, I'm wondering whether the procedure of the WLTC, of the cycle, includes some preconditioning. Because, for example, for internal combustion engines, you have a soaking time between 36 hours or so. I wonder whether the cycle for a pure electric vehicle is all, and you have for hybrid powertrains, charge sustain and charge deplete. So I wonder whether WLTP for electric vehicles, pure electric vehicles, have from plugged or from unplugged. Does anybody know how the procedure is?
If I don't make any mistakes, WLTP is just normal driving unplugged, and then they plug back in and count the charging. So your charging losses are included in.
How long is the soak from unplugged then?
This I don't know.
Because I was thinking about it, since the internal combustion engine has thermal inertias, and I'm actually have a patent on an idea to preserve it in a smart way, I think. Look it up. Then I needed to know, okay, how long do I reasonably need to keep this heat in this thermos? Well, it's patented as well. So that I will satisfy the preconditioning soaking part of the WLTP. Which leads back to regulations rather than real life, which is a silly way to constrain engineering, I would say.
Yeah, and at the end, it's in several areas already different measures. In China, for example, nobody cares about the WLTP.
No.
Even internally, we're of course setting some targets on WLTP, but we're also considering real range behavior. So we also have our internal targets for highway driving, let's say, for which we have our own speed profiles, etc. So I think in general it would be interesting to kind of have this standardized and then to be able to, like WLTP.
And a fair game, because if you bring in China right away, my understanding is that the expected life for a vehicle is 10 years. And we don't design for 10 years. So already off the bat, all the system in the vehicle have a completely different cost to life ratio. Yes. So it's definitely not the same field, battlefield.
Maybe goes more in the direction a mobile phone on 4 wheels, or?
Yes, then I am happy to do what I'm paid for, but that wouldn't be my choice personally. I'm an engineer after all.
I think you touched a very important point about the comfort, and we all know that BEVs in cold conditions, the HVAC just literally bleeding the battery energy. So for me, a way to think about intelligence is like if I'm driving alone on the BEV, what the HVAC system is to warm up the passenger side when it's not needed. Why all the energy should be focused onto the real person who is in the car and not heating up the environment for nothing. This is just could be a way I'm thinking about intelligence. Do you also have any in mind, any idea in mind? OEM suppliers?
Yeah, there are different approaches from different OEMs. There are, for example, HVAC systems who differentiate between different people. So there are split ones and there are centralized ones. So the centralized ones, as you mentioned, just heat up the entire cabin with one outlet or outlets in the front and maybe split into outlets on the backside. And then there are ones who differentiate between the different positions. So for the driver, for the passenger in the front, and for the passengers in the rear. So there are solutions for that one. However, heating up air in general is not the most efficient way in this case. When you have when you only have one passenger or one driver in the car, then there are also clever ways to get a more efficient thermal management system, which is, for example, surface heating. So you still need to heat up the air to some extent. This will always be the case, for example, for defrosting the windshield and to make sure that it doesn't freeze or fog again. So you will always need to have some air conditioning. But for the passenger comfort, there are also different solutions, like heated seats, for example, one of them, then heated steering wheel, surface heaters, infrared heaters. So there are different approaches to make energy use more efficient for comfort than just plain air heating.
And a comment on that, I think already for a while, at least in North America, California, if I don't remember, don't quote me on this, you had fuel consumption credit for internal combustion engine vehicle if you have cooled seats, because then you're cooling just the seat with the blowing air, right? And then lowers the demand on the AC system, and that will impact fuel consumption. So that is definitely something that is used and, well, to some extent implemented in the regulation.
In China, you pay as well less tax for a vehicle if it's more efficient. Yeah? So they have as well this, so far I know, still this value for a BEV vehicle. If it's more efficient, you pay less tax for a certain amount. Maybe not half, but,
no,
but some percentages at least. Yeah. And another thing what I have recognized is, for sure, you can switch off the air outlet somewhere in the vehicle, even if you cool it down and only cool it in the area of the driver if nobody else is in the vehicle. But if it's really hot and you drive on a highway and you make some curves, so you really feel that then the hot air goes circling around. Yeah. So the question is then again what comfort or what efficiency leverage you have in the vehicle. Yeah? And this was a funny discussions we had internally with our experts from the simulation who simulate as well this comfort behavior. And the first told me, no, that cannot be. And I said, we can make a test drive if you want. And then they come back, yeah, you're right. So there is definitely some trade-offs on the one hand. On the other hand, as well agree to this infrared heat surfaces topic. I cannot understand why we still blowing the hot air in the face if there's already another technology available on the market. So there are many OEMs who have it in part of their vehicle to have already this infrared surface heating, but I know no vehicle which goes with poor infrared heat surfaces in that at the moment, so far I know. Did you know something? No.
Not that I'm aware of.
So you would recommend removing the HVAC and just improve?
No, for sure you cannot do this.
As mentioned, we need it for defrosting, defogging.
I mean, the challenge, if I understand, with infrared heating is that you are likely to be able to touch these surfaces, so they need to have a certain balance of thermal capacity, so in case you get in contact with them, that you will not burn yourself or your children.
Sure, there's some safety relevant
Yeah.
topics.
So, and then eventually find out a cost-effective way of doing it to be like,
But there are as well some technologies, because we worked with that as well quite deep in the beginning, where you have negative temperature coefficient, so that the material itself, if you calculate it right with the thickness, has a maximum temperature, and you cannot go above that.
Yeah.
So there are a lot of things what you can do. And as mentioned, I guess BMW has already many through faces in the iX, where you have heated through faces, as well in the rear side on door panels. A lot of vehicles are already with the BMW 7, I guess, heated or something like that. So it comes around.
I'm surprised that your colleagues did not believe that air density plays a role if you're taking a sharp turn at several Gs.
We can discuss this later.
Yes, I'm like, okay.
Wanted to add some questions in this thermal comfort of the passenger, right? So we are talking about different options, how to make the user, the driver, and the passengers more comfortable while they're driving. I want to ask you something, like who of you guys have the system in automatic? 2 out of 5.
It depends on the day.
You see? So, I mean, we are, I don't have it, that's what I'm asking, because I mean, we have it, we have several ways of making the system super smart, but at the end of the day, if the user doesn't use it,
It depends as well on the vehicle, I guess.
Exactly, because that's the question, is does it overlap with people having an electric car?
Yeah.
Because I have not an electric car, and I don't experience any of the issues that we are discussing about at the moment.
Yeah,
But- Sorry.
I can agree on what you said, because it depends on the vehicle. Some actually really have a good smart system.
Agreed.
So personally, I have an issue if I notice a lot of air blowing to my face, for example, then I cannot stand it.
Yeah.
So I noticed some HVACs in some settings for the HVACs, and blowers, they do not have a good setting, so I will not set them on automatic.
Automatic, yeah, fine.
But right
But
now,
you don't change it as a function of how many people are in the car,
Yeah.
right? You just leave it there.
and,
Exactly.
but do you select from where you want the air to be blown? It's your face or your feet, or does your car does it automatically and chooses up and down and so on?
no, the way the air blows can be set up manually.
Exactly.
However, I noticed, depending still where it blows, there's still, let's say it blows to the lower body or to the stomach, then still you have some airstream going upward, for example. And I noticed that whenever I have airflow around my eyes, then my eyes are getting dry, for example.
Yeah.
And I noticed some are having not a good setup for this, and others have. And for example, right now I'm satisfied with the automatic option because the air flow is not that strong that is needed, and the HVAC system is set up well that I do not have any airstream near my eyes.
So there is some room of improvement of the current systems without going into super complex modeling, right? Like.
I guess you're also hinting towards getting feedback from the customer, some way to optimize it. And the only way you can do it is to look at which buttons are they pressing manually first, learning from that, and then actually implement.
Yeah. And also another point, in my opinion, is how the system measure your comfort to actuate, base it on the temperature of room temperature, base it on the temperature of the user. This is the key. Probably it's not the same from all OEMs.
Then a question on efficiency. So in your opinion, or maybe in your research on how low can we go in power use of thermal management system? Like, do you know a lower bound of this power use? How far can we go in efficiency improvement?
Maybe can you rephrase the question? I don't understand.
Say you have like infinite intelligence
Yeah.
in your thermal management system. How much can you optimize?
Okay, how many kilometers you save, you mean, on the range?
Exactly,
or,
like
okay.
driving range or power use. Yes.
Okay.
Then the question becomes what's feasible in some way. Like, I think we generally kind of know that in lower temperatures our HVAC system comes up to even 50%, up to 50% of the total energy consumption.
In some conditions, yes.
Some conditions can happen at lower
Other
temperatures.
conditions.
And say you drive this efficiently, I mean, can you really save? Because at the end, you still need your passenger to be comfortable. There still needs to be some heat provided. So what is really the gap between that absolute needed and what you are providing?
I guess it's a question as well, where is the starting point? Yeah? So if you have a very pure system, you can gain a lot with a intelligent control, but you would gain as well with a better calibration of the system a lot already. So there's as well the question, what helps these root cause topics to take the decision by a model and not by default, let's say. Yeah. And then it's a question mark how good the system is set it for one area, for one people. Then I would believe there is not really much different. But if you then say you have one vehicle which you want to launch in several areas, you might have in total a big benefit of an intelligent system.
Mm-hmm. And it's also ambient temperature dependent.
Yeah.
So for example, if you have 5-degree ambient temperature, then you could start from a system always forcing to blow 10 kilowatt of heating performance into the system, like battery and cabin. And then of course the potential is huge, because you at 5 degree you can still use the heat pump very well, very efficient. And then with combination of surface heating, for example, then you will probably get, I guess, 70–80% efficiency gain. And if you already started an efficient system, so where you use the heat pump, where you do not use too much energy, and you can still optimize it, I guess there's still some gains possible.
I guess I remember we had one project where we had some kilometers more saved on a predictive model base there. So it was not really that you can go from 50% less to only 20% less. Yeah. So there's definitely small leverage on that, in my opinion.
Yeah. Okay, thank you. Yeah.
One small comment that I wanted to add was maybe you have this kind of steady state, of course, power consumption, but one could also consider special cases or specific use cases where people drive only short distances, and then you can kind of solve a bit better your problem by smart preheating or reconditioning of cabin or battery, which we already have somewhat, but maybe we can do it in a more smart way.
Because I was thinking, right, you are always going to run out of energy when you need it in a pure electric vehicle. So the smartness might well be the ability to know what your actual range is in a trustworthy way, so you can plan your forced stop, because you know you're going to stop. The problem is that, well, I don't know if it is in 10, 15 kilometers, and that keeps changing all the time. But if you can trust that this thing is reliable in telling you how short you will get, then you can actually relax, you get there, and then plan it.
Yeah, solving a bit the range anxiety, I see.
Yes, because at the end of the day, you know you're going to run out of energy. There is no way around physics.
But I guess there are many parameters. If you would know exactly that this charging station is free and available when you are there, you block it for that, and you are sure that it is working.
That's part of the intelligence.
Exactly.
Right? Part of the intelligence, you say, okay, I am guaranteed to make it there, because that, my understanding, is not always the case. Right? The range goes down. I'm guaranteed to make it there, and I ask, are you there? Yes. Are you free? Yes. Can you stay there for me, please? I'm cold. And then you flip the script, right? You get rid of the anxiety, because you can actually intelligently plan your trip, rather than have toddlers in the car that ask you to stop immediately because they need to pee or anything.
And you can more precise calculate as well when you heat the battery or something like that with a better model or something like that, as you mentioned before. If the model is already maybe not accurate enough, then the best predictive will not help you.
Exactly. You know you're going to charge. You have preconditioned your battery cooling or heating, so can actually take that amount of power that you might have or intelligently predict that if it is 50 or 100 kilowatts. So in that sense, it would make your life easier.
Yeah. Yeah. Could the state of charge not also solve that? Probably with some good sensor on state.
Exactly. I mean, how good? Otherwise, you would already have the range that actually is correct.
Yeah.
If you knew, if it was that easy.
Yeah, and still a question, Christof, on what you said. So you said, so if you have someone that drives the car always for short terms, and you have someone that drives it always for long, like say you would optimize your thermal management system for that, for those specific people, how much kind of driving range do you see could you improve? Could you quantify or put a number?
That's a good question.
Yeah.
There's a lot of dependencies here, but rough numbers speaking, you would not need this initial heating ramp up, which can take, and I'm generally speaking, up to 7-8 kilowatts. And you would only need a stable 1-2 kilowatts depending on vehicle. Of course, this doesn't give you the kilowatt hours per 100 kilometer because it depends on the speed you're driving.
Yeah.
But this gives you a range of 5-6 kilowatt increase over that first maybe half an hour, 15 minutes driving.
Yeah. Okay. Yeah. Thank you.
Additional questions regarding intelligence. So, so the question is regarding smart intelligence. So how you see this intelligence terminal management will be connected in the future in the autonomous driving, smart city? I think you speak about this usage of mobility in the future will be changed. So we don't speak about I have a car, I use mobility from A to B, so it's more car sharing or something like that. It can be possible you are not a fan of that, but it's will be coming, especially with the generation Z and the future. It is a preparation for this next level, what we are speaking about, or it's more now it needs in the current market. So we need to have an intelligence terminal management system, to have a comfort to drive, to have the right time to charge my battery in the right systems, or it's more preparation for the next level. It's we speak about autonomous driving, we speak about humanoid robotic. It's also something which is coming in the future. So,
I know from our side we're just focusing currently on the traditional way of working for vehicles, but actually raise a good point that maybe we should consider, because probably a lot of those learnings can be applied for those applications. So,
okay.
Yeah, that's actually a very interesting use case. For example, looking at people movers, so autonomous driving, when you have vehicles who are not driven by just one person, but maybe one vehicle that is driving throughout multiple hours, that needs to be charged, but is driving all the way, all the time. So basically in the beginning you need to heat up the cabin, the battery one time, and then it's in a steady state for multiple hours. So you take out all the losses you need, for example, for always having a ramp-up process and then cooling down again, which saves a lot of energy overall.
And I can imagine that if you're sharing a vehicle, you probably have to consider the quality of the air inside it. I mean, it's probably going to be more like a thermal equilibrium. The vehicle is warm. But when you step inside, you probably wish to have fresh air in there, which is a loss. So you will have to have a heat recuperation system in order to get the range.
I mean, in the HVACs, it's usually a mixture of fresh air.
Yes, yes. But
also
if you stand in the car after somebody else has been there, you might want a whole, not a blend.
There came as well the sanification topics during the COVID time with UV light and something like that to make sure that the virus and all that stuff gets killed. So there was a lot of action in that direction, but it was a hype, in my opinion, and it was going down as well somehow again. But definitely if you share the cars in that way and you want to be a very comfortable and safe and secure supplier, then this is a big topic, I guess, as well. Yeah. On the other hand, if you have sensors in the vehicle to predict when the CO2 concentration is too high and all that stuff, this helps as well a lot for the efficiency. If you would know exactly when you should open and not just say the first minutes to be on the safe side or whatever in a vehicle. Yeah? So there are different control logics at the moment on the market, in my opinion, and not everybody doing it in the same way.
Also on this point, maybe my first concern would not be on the efficiency. Because if you go into this car sharing or smart mobility or just like lending a car for 5 minutes or autonomous driving, whatever, the key element will be there, the problems that we face for taxi drivers, which is fast charging. They need this vehicle to be operatable almost any time. And sometimes we have limitations on the fast charging. Sometimes you're limited to the number of charges you can do before some control logic takes over to save the battery.
Mm-hmm.
And also because the fast charging is very low from thermal point of view in extreme conditions. For example, in summer, whatever, it's important to consider not only the vehicle, but also the charger and the entire ecosystems.
Yeah, many times I had the experience go to a charging station at 30-something degrees outside. Charging station is in the sun and it's not operation. Yeah.
Yeah. And also because probably in some years fast charging is the standard. And we need to be ready for this change.
I guess we now left a little bit the topic. So is there any question bringing us backwards on the track from the audience?
I can always tell what horsepower train is as a backup topic.
Just a question: is thermal management or good thermal management, could it also improve or speed up the charging time?
I guess it's proven with battery preheating. Kind of gives you the answer away.
Yeah. To some extent, for example, if you look at benchmarks, you can also find a lot of YouTube videos, for example, about investigations, how fast actually fast charging is for different vehicles. Then you usually see that when 150, 400 kilowatt of charging power is proposed by an OEM, then the curve is not like stable instant 400 kilowatt and stable then for minutes, but it's usually some ramp up, then it has a peak for some time, and then it's going down. So yes, this is exactly what you
but that I believe is more a chemistry point of view limitation rather than thermal management, no?
Actually, it's a mixture of both. So yes, chemistry is one of the issues. So usually, depending on the state of charge, there is some limitation based on the state of charge.
Yeah, I was assuming this.
Yes, and the other one is the thermal management. So having the battery at a proper temperature, 25 degrees or higher, and then at some point keeping it within its ideal temperature range. So you need a good cooling.
Okay, so I guess we are somehow at the end of time. I personally know a lot about horse powertrain, but I guess the audience maybe not. So
if you lift your hand because you want to know, I'll tell you. Otherwise, I will not tell you.
So if
one,
I would definitely say if you make it in a.
Is it worth telling?
Yeah, sure, do it. We have
so
one minute left.
Powertrain. Now I'm standing, so it's over. We have Geely Holding that create Aurobay. That's the powertrain, the leftover of engine development for Volvo cars and for the Geely group. And then on the other side, you have Renault Group making Horse, which is the powertrain manufacturer for the Renault Group. And then these two met and they join forces. So the joint venture is called Horse Powertrain Limited. And we make from pure electric to pure ICE solution. That includes our core business, hybrid powertrain. And I usually say the size of it gives a bit of a matter. If this is off the record, but we should be between the third and the largest powertrain tier 1 producer in the world after Toyota and Volkswagen Group. So we make quite a few engines and complete powertrain to sell to any OEM that will wish to buy them. I also will take a pick from what you said today, and having an electric vehicle and a battery in the car is like having a teenager, and we are the adult in the car.
Thanks a lot.
We'll take you home.
Very impressive, to be honest.
It's going great. Physics has the last word.
So, but coming back to our discussion as well, thanks a lot to the team. It was great being with you together on the stage as well. Thanks to the audience. I guess we did together a great job.
Yes. Thank you.